Alright guys, here are our notes for similar triangles. We talked about similar figures. Now we're going to talk about how to prove if two triangles are similar. We've talked about how to prove if two triangles are congruent, same shape, same size. Now we're going to talk about similar, where they have the same shape but not the same size. First thing we discuss here is a reminder that similar triangles have corresponding angles that are congruent, and their corresponding sides are going to be proportional. The first one that we are going to talk about is your angle-angle similarity theorem, your AA. So this is familiar with letters that we talked about with congruency, but now we have a few different things going on here. This states that if two angles of one triangle are congruent to two angles of another triangle, then they are similar. Okay, we take a look here. We're told that angle C and angle F are going to be congruent, and so angle D and angle A are congruent to each other. So therefore, all we need are two angles, because that means automatically the third angle, angle B and E, have to be the same in order for them to add up to 180 degrees. So we're able to say that triangle ABC is similar to triangle DEF. So let's take a look at an example. I really like these examples here because these are some that some students don't notice what's actually going on in the picture. Letter A here, what we need to focus on, please put this asterisk here. You need to look what's called, like when we talked about shared sides, we're not going to have that now, but we're going to have shared angles. So you must look for shared angles. And that's going to be this angle A right here. Now we can already tell here that angle B and angle C are going to be congruent because they have the same measurement. But here, angle A will be congruent to angle A. What the heck does that mean? Let's take a look and let's pull these two triangles apart. What we have is triangle AEB is inside of triangle ADC. So we pull this apart. Here's our triangle ABE, where we have that 52 degrees here, and then we have that shared angle. Okay, it's going to be the small one right here. But then we also have the larger outer angle that angle goes inside of. Okay, so here we have the A up here. We have the C down here. And then down here we have D. So all they've done is they've taken the little triangle and they put it right in that little spot. So they're going to share that angle. And so they're asking, can it be proven by AA similarity? If so, write a similarity statement. So because we do have two congruent angles, because of that shared angle, we will say yes. And in your similarity statement, we could say triangle ABE is similar to triangle, now A corresponds with itself, A. B was the 52 degrees, so we have to use C, it corresponds. And then D. And there's our answer to the first one. On B, this is one where we're going to have to, just like when we did congruent triangles, we're going to have to pay attention and we're going to have to look for vertical angles. Okay, so those vertical angles we have right here. So since we have those vertical angles now, we can see that angle J is congruent to angle F, and we can see that angle JHK is congruent to angle FHG. So we do have another pair of two pairs of congruent angles. So here we'll say yes, and we'll say triangle. We'll start up here with the one arc, J. I'll go down to the vertical angle, H. Down here to K, triangle JHK is similar to triangle, so J corresponds with F. H, the vertical angle, is going to correspond with itself, and then up to G. And there's our answer for that. Another thing that you may see is two angle measurements on one, and then two angle measurements on another, where you can see one of them is congruent, but the other one's not, and you'll have to use the triangle sum theorem to figure out if that third angle is congruent. Okay, I'll take a look at the assignment and see if I should do one of those on the video as well. Your next one is going to start on this page. We couldn't quite get it all on the same page. You do have a side-side-side theorem. Now your SSS is not like the congruent triangles where all three corresponding sides are congruent, because remember, they're not congruent, they're now proportional. So what we did in the previous notes of trying to figure out if two shapes were similar, what we have to do is we're going to do the exact same thing. Find all three sides and figure out if they have the same ratio, the same scale factor. So this is saying if your corresponding side lengths of two triangles are proportional, then your triangles are similar. So it's saying that if AB to RS, these corresponding sides, is equal to BC and ST, and it's also equal to CA and TR, then they're going to be similar. Of course, this little setup looks a little weird, so let's do an example. This is where in my notes on my video and in my classes, I labeled small, medium, and large. We want to know, can they be proven by SSS similarity? If so, write the statement. So we're going to go through and let's go ahead and find on the first triangle right here, let's find our small side, our middle or medium side, and our large side. Over here, same thing. Here's our small, here's our medium, and here's our large. And we're going to do the exact same thing, and we're going to set it up just like we did in the other notes, small, medium, and large, and we're going to set up these ratios to see if they all come out to be the exact same. Starting with our small, it doesn't matter which one goes on top or bottom as long as you stay consistent. If I put the 3 on top here, I'm going to put the 9 on the bottom. This will simplify to 1/3. Now, because I started over here with the 3 on top, this triangle on top, I have to stay the same way with the medium and the large. So when I go to the medium, I need the 4 on top. Over here, my medium was 12. And this simplifies down to 1/3 also. So far, so good. The third one has to be checked. If it is not 1/3, we do not have similar triangles. So here again, starting with this triangle when it's on top, put that 5. Over the large side, that 15. And lo and behold, it does come down to 1/3. So here we can say, yes, they are similar. And our similarity statement, we'll say triangle. I'll just go ahead and put STU is similar to triangle XWV. Barely had room to write that in, but I got it. Now it doesn't even look like the letter V anymore. It is, though. Let me make it a little neater. Okay. STU, similar to XWV. The last one we're going to talk about here is your side angle side. These are the only 3 that can prove similarity. Okay, your side angle sides, we just like the other one. The side angle side with congruent, except again, we're looking for proportional sides. So we're looking at an angle of one triangle is congruent to the angle of the second triangle, and the lengths of the sides, including the angle, where the angle has to be included between the two sides, they're proportional, then we have similar triangles. So rather than go through this, we're just looking at, we've got to have AC, okay? They're saying CA and FD right here are going to be proportional. You've got the other side, on the other side of the angle, you got EF and CB, and you have that included angle right there. Again, these can be a little weird looking, so let's just jump straight into looking at some examples here. Again, can they be proven by SAS? If so, write the similarity statement. Well, the first thing that I'm noticing here is that I have congruent angles. Okay, so I have my A. And I also notice that the two sides, okay, they create that angle. So that angle is included between these two sides. But we have to figure out if those two sides are proportional, just like we did up here, but now we only have to do 2 of them. Okay, we don't have to do the small, medium, and large. So here I have my small side and my large side. This guy over here, here's my small side, here's my large side. So we'll just compare these two because we have that angle included between them. So our small, we'll set up just like we've done. Put that 4 over the other small, 6. Or if you want to do 6 over 4, that's fine. This is going to simplify down to 2/3. Then we take a look at the large side. Again, we use this triangle right here, LMN, for the top up here, so we have to stay with it on the top for the large. 6 over the 9. And this will end up simplifying down to 2/3 also. And we also have our angle here. So, yes, we will have similar triangles based on SAS. So we'll put triangle LMN is similar to triangle QPR. All right, now we're going to determine whether these two triangles are similar and write our similarity statement. You might want to write a little small on these. I'll go ahead and give you a little forewarning. The first one here, what I'm noticing is I'm noticing a shared angle right here. Okay, so we'll make sure that we make note of that. We have a shared angle. So I'm going to separate these two triangles because here's the other thing. We right now, the smaller triangle, KLM, we have the two sides with that included angle. But the larger one, JLN, we don't have. 3 is not the side length. We're going to have to combine these together. Okay, so what I'm going to do is I'm going to draw, I'm going to end up using a lot of room down here, but I'm going to go ahead and draw LKM. LKM. Here's our congruent angle. Here's the 6, and here's 10. Now I'm going to draw LJN. So here's L, that congruent angle, that shared angle. Here's J, and here's N. Now the whole side is going to include that 6 and the 3. So we have to do 6 plus 3 to give us 9 as our side length. Over here we have the 10 plus the 15. So we take 10 plus, I'm sorry, not 15, plus 5. I can make that into a 5. Plus 5. We're going to end up with, there's where I got the 15 side length. Okay? So I'm going to switch colors, make this a little bit easier to see the difference between these. When we look at we got our angle, we got the angle included, we need to find out, do our small sides and do our large sides, are they going to have the same ratio or scale factor, just like example 3 right here. So here I've got my small side and I have my large side. And this guy over here, LJN, I have my small side and my large side. So we'll set up the small, 6 over 9. This will come down to, we actually just saw this, 2/3. And we'll take our large side, 10 over 15. Got to squish those together a little bit, didn't I? And this is going to end up coming out to 2/3 also. So we have our angle, and we have our included angle and our two sides. So up here we can go ahead and write in, yes, they are similar. And we could call this triangle LKM is going to be similar to triangle L, go down the same side, J over to N. And there's our answer to that. Now when we look at B, what we're going to need to notice here is that we do not have a shared side. Okay? The top triangle has side DE, EG, and GD. Okay? The larger triangle has EF. G has nothing to do with it. EF, FH, and HE. So we need to see our sides here. The first triangle here, the smaller one here, okay, this guy. Here are our sides. We have 3 as our small side. We have 5 as our medium side, and we have 6 as our large side. When we look at the bigger triangle here, okay, this is what we're looking at. What we need to notice is we're going to have to add from EG and from GF to get the entire side length of EF, and this will end up being 12. So now here I have my small side, my medium side, and my large side. So we have sides, so we need to go ahead and compare all 3 of these together to see what happens with our answer. So here, let's look at our small. We're going to take that 3 over the small side here, 6. So 3 over 6. This will simplify down to 1/2. Let's take our medium sides, 5 over 10. We see, okay, cool, that's 1/2 also, so far so good. Make sure we check out that last one, your large, 6 over the large, 12. And we do have another 1/2. So we can say, yes, these are similar. And we could say triangle EDG is similar to triangle. And this is where it kind of gets a little rough about which ones go together. Well, we started with E and D. That was the shorter side. So here I'm going to go to the shorter side, FH. So F to H to E. You usually do not get ones this difficult to name. Okay. Our last example here. The first thing that I want you guys to see is that we do have we do have vertical angles here. So we could end up with a side angle side. So here, note, vertical angles. And then so we actually don't even need to use the 6 and the 15, yet it is suggested you go ahead and use those to make sure that they do come out proportional as well. So we can see we might be able to prove this as SAS, or we may be able to prove it as SSS. Okay, so let's take a look at our small, medium, and larges here. We got our small side, medium side, and large side. Down here we can see 12.5 is going to be our small side. This will be our medium. 20 will be our large. So if we take a look at our small, okay, I'm going to put the 12.5, I'm going to change it up a little bit, 12.5 over the small side over here, 5. When you plug this into the calculator, you're going to wind up with 2.5. Let's take a look at our medium side. We're going to do the 15, excuse me, over the 6. And when you go through and you plug this into the calculator, 6 will go into 15 2.5 times. So far so good. Let's take a look at that large side. We have at 20 over the large side here, 8. This will also become 2.5. So in reality, you can actually use this. We're going to say, yes, they're similar. We're going to say triangle. I'm going to start with the vertical angle, R, go down the smaller side, Q, over to P, is similar to triangle, start with the vertical angle, R, go down the smaller side to T, over to S. And one thing I did leave out on the other ones was we want to know which theorem proves. Okay, this can be proven by SSS or SAS. So you got a couple different things here. Let's go back and look at A and B real quick. A, we found that angle and the included angle between the two sides. So whenever not only did we find out they were similar, but we want to add in here, I'm going to erase this line. These are similar by your side angle side, because we had our side angle side. On B, we found out we used all three sides, so this is by SSS, by your side angle, sorry, your side. And these are different ways, your three different ways of showing your similar triangles with angle, side, or side, angle, side.